This is the EdExcel Chapter 7, Exercise 7A, which deals with P3 integration. I'm looking at question 2. So question 2, we have something that is not on our usual list. So I'll bring up that list in the beginning of the video for you quickly. This list you can find in the textbook, and these are all the common integrals that we can work with. So as you can see, there's no cos squared x that we could work with here. So we want to make it look like one of these 9 integrals so that we can work with it. So the suggestion is to always make it look like one of these, and then you can automatically just take it through. So we have currently 1 over cos squared x, and I'm going to immediately put the other one is x to the minus 2, because that will be easier to work with. So how do we change 1 over cos squared x? The simplest way is to notice that if we have sec squared x, the reciprocal is 1 over cos squared x. And we're going this way. So if you change it to sec squared x is straight to tan x. So that's one of our 9 options, and we can continue from there. So our integrand becomes, before we do that, let's just rewrite it. So this is actually sec squared x plus x to the minus 2. This is number 2a. Okay. So we're integrating this with respect to x. Sec squared x is one of our options. That just becomes tan x. When we integrate something with a negative exponent, as long as it's not 1, you just plus 1 and you divide by the new number. So it will end up being x to the power of minus 1, minus 2 plus 1 over minus 1. Don't forget plus c. So we have tan x minus 1 times plus 1 is just going to be x, negative x minus 1 plus c. And for the answers there, do prefer that you put positive exponent form. So tan x would be, oopsie, let's do it like 1 over x plus c. Okay. Let's look at number B. Again, thinking in your mind, what do we need to change so that it looks like something we can work with easily? Like how can we make something complicated look like something easy? In previous videos, we've sorted out what to do with EX. EX just stays the same, and you bring down the 2 because it's a value. It's a constant value attached to the EX, so that's all good. But the sine x and cos squared x is a little bit worrying. So I'm going to split it up. This is the same thing as this. So I've just split the cos squared x into 1 over cos x and sine over x. So that we still can't use. The 2ex, I'm not worried about at all. Let's see if we can change this again. Sine over x we know is just tan x. So that solves that. And 1 over cos is actually just sec x. And here we have one of our options. So tan x sec x, is it automatically an option? That just goes to sec x. Okay, if you look at your list, that just goes to sec x. So now we can continue with our integration. We've made it. Okay. So our integrand tan x sec x is just going to be sec x. 2ex just stays as 2ex. And don't forget that you have to plus c. Number C. Number C, so again, we want to make it look like one of these 9. So first thing I want to do is split this 1 plus cos x over sine squared x into 1 over sine squared x plus cos x over sine squared x. And this is 1 over x squared plus x over x squared. So I split up both those terms into 4 terms. Now each of these is, so we look over here and we do we have a sine squared x? No, but we do have a cosec squared x. So for the first one, 1 over sine squared x is just cosec. Do we have a cos over sine? No, we don't have a cos over sine. So we need to do quite a lot more with that middle one. Let's change it let's change it to cos over sine. Oopsie. Let's change it to cos over sine times 1 over sine for now. X squared, oh, it's not 1, so we can just say x to the minus 2. And this cancels. So we actually have 1 over x, which is going to be a ln situation. So already it's looking better, much more like something we can handle. Just one more step maybe. So we have cosec squared x, cos over sine. Let's see, what can we change that to? Well, tan. Let's try tan. If we had that as tan x, it would be tan x times sine. Oh, that's not tan. That's cot, because it's the reciprocal of tan. Okay, that makes it much easier. Okay, so we have cot x cosec. 1 over sine is cosec. So now I see that's the one I'm using, number 7. And the rest we've dealt with already. Okay. So finally, we are ready to quickly differentiate this. So cosec is this one, just going to go to negative cos. Cot cosec is this one, just going to go to negative cosec. And we have a ln function. Okay. And the first one is just a usual differentiation. +1 over n plus 1. Okay. So let's do cosec first. Our integrand is going to be negative cot x. And then we have the second one is just going to be negative cosec x. Oopsie. X to the power of -2 + 1 over -2 + 1. So that'll end up being in the denominator. It's negative because -1. And it'll be, sorry, not in the, there we go, in the denominator. And finally, 1 over x just becomes ln x. And don't forget plus c. That was question 2C. Besides having to change it into one of these 9 forms, you might also have to take out a common factor or manipulate in some other way. So let's look at question 2E. I'll leave out D. So question 2E. I see they actually already took it out. So they've reversed it. So first, question 2E, you first times it in. So sine x plus sine x sec squared x. So just times that in with respect to x. Okay, so where I foresee a problem when I look at this, obviously would be this funny looking thing. We have a sec squared x. We don't have a sine sec squared x. So we need to simplify it a little bit more. The sine x is still fine. Let's separate this into sine x times by sec x times sec x. See if that helps. Not quite. But we know that sec x is 1 over cos. So if we simplify this to sine x plus sine x times 1 over cos x times another 1 over cos x. This, obviously doing this the long way around. Well, let me keep that there for you. There you go. What we're wanting is for it to look like one of these on the right. So if I'm looking at this, this is actually sine over cos, which is tan. And then if you have tan x sec x, 1 over cos is just sec. So just to look at where I got that from. Oopsie. Color. There we go. Tan sec. Yes. That's so as I said, like memorizing this list is probably the most important thing you can do for P3. We now have something that will work. We have a form that we can integrate, and our final integral sine goes to negative cos. Tan sec goes to just sec. And don't forget, it's indefinite, so plus C. That was question 2E.